So remember, one part of RSA, you have to have P and Q, and they have to be large prime numbers. And we didn't talk about how do you find large prime numbers, which is not that easy. So it turns out there's a thing called Fermat's little theorem, which is pretty awesome, that if P is prime and A is not divisible by P, then A to the P minus 1 is 1 mod P. This is Fermat's little theorem. And what that means is you can just test this for numbers, and this will work if they're prime, and if they're not prime, it will usually not work. Sometimes it'll work even if they're not prime, though. So this is the trick. The way you find a prime number is you don't prove perfectly that it's prime. You have a statistical test that will detect non-primes to a certain probability, and you run it several times until the probability of being prime is pretty high. Then you use it, and if you want to finish it, you try encrypting data and decrypting it, and it won't work unless it really was a prime.
There was also a formula that you was using the log, I think.
We'll get there. Yeah. Yeah. So this is the first. So you can use this statistical test to find with relatively high certainty whether something is prime. But then the question is, how hard will it be to find a prime number? And so here's the first one. Let's start with this. Here's a file that will detect prime numbers, fermat.py. I probably already have it there. I do. All right, let me put this down because it's not covered by my face. And there. So here's the code that does this. I input a potential prime number, and for 5 times, it's going to pick a random integer from 2 to P minus 2, and then it's going to try to do this Fermat thing. Take the random thing to P minus 1 mod P and see if it's 1. So it's just going to try random numbers. Any value of A, it should always be 1. And so it'll tell you how many times it passes and fails. So if I run this, Python 3, this is the Fermat test. Okay, and I put in, say, 11, it passes, because that's prime. It passes 5 times. If I put in, say, 100, it fails every time, because that's not prime. If I put in 101, it passes, because that's prime. And because all I'm having to do is modular arithmetic, it's very fast. So you can even put in a really big prime number, like this one. There's a prime number that's 1,024 bits long. So I can run this test, and it takes no time at all. Because raising something to a power modulus something is really quite fast. It doesn't get very big. And so you see it's passed 5 times. So the odds are pretty good that this is a prime number. So now the question is, how dense are the primes? How many guesses will I have to make to find a prime number? And that's what you're getting here. This is the prime number theorem, the famous theorem. The density of primes follows 1 over log of n. So it falls very slowly. So you can calculate the density of primes here. And so that's density. Let's clear and cat. Let me make this over there is probably the best thing to do. Cat density of prime. Okay. So now this is just going to n is 10 to the x, input x, right. So I can take 10 to something, it'll tell me the density of primes in that region. So if I run this, Python 3 density, okay, so if I have 10 to the 1, that's 10, and so the primes are like 43% of the time. There are prime numbers there. But if I have 10 to the 10, it's 4%. And if I have 10 to the 100, it's 0.4%, which is really not that bad. Now, 100 digits is like 300 bits. Now, you know, these days we're supposed to have 2,000 or 3,000 bit keys. So it would be 300 would be 1,000 bits. So 1,000 would be 3,000 bits. So 10 to the 1,000. 1,000 digit decimal numbers are what we're using now for keys. And there you see it's 0.04%. So you'll have 4 primes in 10,000. That's how hard it's going to be to find. You'll have to guess 10,000 numbers to find a prime number, approximately. So that's not impossible. And you see it grows very slowly. So the primes are thicker than I thought they would be when I first learned this. So now you can find prime numbers. It's real simple. You're just going to have to write code that will start. So you start with this number. This number is not prime, 10 to the 300. So find the first number above it that's prime. Just make a counter that counts up until you find a prime number. And here's the test. Anything that passes this test 5 times, it's prime. So you have to write a little bit of code to do this one. But that's the game. And here's, you can find companion primes. There are prime numbers that are separated by only 2, like 11 and 13. Those are called companion primes. So find the first companion prime above 10 to the 100. So you have to find a prime and then test the one 2 above it. It has to also be prime, otherwise quit and go forward. Both of those are much easier than you'd think they would be, because the test is very fast and Python is very fast. And Python is always precise when doing integer operations. You don't have to do anything special. You can have integers as long as you want, and it will always get them right. So that's pretty easy to do in Python, and that's all you have to do for this project. So let me stop this video.